Hello everybody and welcome back. We're here at MACH 2024 and we are on the Star Stand.
We are. I'm so excited. As always, they've got a fantastic component to show us. It's quite a lot of components actually. It all comes together in a beautiful assembly though.
I don't want to show you. I'm not going to show you yet.
It needs to be a grand reveal, right?
It has. How's MACH been for you?
Pretty nice. It's Wednesday afternoon. I'm feeling good. Like you said yesterday on the podcast, you said it's been feeling a long time, feeling like months, maybe, maybe years.
I love it. You were like, it's really busy and I'm tired and I don't know why. I'm like, it's because we're chatting all day long, but it's great fun. We love it. And it's so good because you walk around and you see people, you know, oh, it's just great. Anyway, so we're here on the Star Stand. Thank you for watching. And we're going to take you on a tour and see, I'm not going to show it you yet, something spectacular that they have created. And I love it because Alex said to me, he said, we're just engineers and we like making fun stuff. And I think
you're almost showing it off there. Keep the hand closed.
But it's true, isn't it?
Absolutely. So it's a fascinating thing we've got to show you today. And what I love about it is all the technology here, everyone walking around is passionate about as well. They're asking questions, they're involved, they're interested. So if you've got any questions at home as well, please get those in. Ask the Star engineers. We're going to be talking to Alec and Chaz, who know a lot about the machinery on show today.
Can I steal that from you?
Oh, if you really, really have to.
Okay, so I'm going to go and speak to Steve, who runs Star. But also, I'm then going to speak to Chaz. And then I'm going to show you the nice component that they've got. And then Rowan is going to go round the stand, maybe talk about some of the debuts that they've got, but also some of the components that are in this work of art. And then you can see some of the machines as well. Steve, come over. Look at him. He's enjoying himself. Can't enjoy yourself.
I'm not sure I do enjoy myself.
Well, this man, I don't know what's going to come out of your mouth when we do the interviews.
My feet are killing.
Yeah, exactly. Right, your stand, it's always busy. You always have a fantastic stand at MACH. You do.
Thank you.
You do. It's busy. There's lots of people here. So far, it's Wednesday. What's been going on?
No, good. 2 years ago it was really good because post-COVID, etc. But yeah, steady flow of people. From sort of 10:30 onwards, you can't talk to everybody. No, lots of faces, old faces, new faces. Yeah, it's very positive.
You've got 3 debuts of machines, haven't you? Can you just tell me just briefly why you've brought them here and kind of the timing of those machines?
Yeah, you're asking the wrong person for this. No, yeah, we've got the NUSB, the SP, SD26. Yeah, it's the opportunity to show a sort of loyal customer base what new that Star have developed.
Actually, I've got an interesting question for you. What conversations have you been having with people where you've found people have repeated? I'm talking about customers. Is there anything that people are repeating that you're like, yeah, that's what vibe you're getting from your customers?
Yeah, interest rates are too high.
Okay then. Well, there you go.
No, they are. It's a constant. It's
that's what I want though.
No, it is. It's but yeah, no. People are okay. The market's a little bit subdued in places. Certain sectors, defence, aerospace, are busy. Others are not. But we go through cycles, and
we do.
And it always comes good again. And this is the opportunity for us now to be showing the people while they've got time to be looking for next purchases. As a sales pitch, the best time to buy is when you're quiet.
There you go. There you go. You're not in sales at all. They haven't seen this yet. They haven't seen this. So I'm going to show you in just a few moments with Chaz. This very exciting.
I don't know how you've got one.
Yeah. Well, this is mine now.
You've obviously ordered a machine.
Well, yes.
Oh, Paul could order it. He's got some money.
There you go. I do enjoy going on camera with you. I'm going to steal that from you. Have you got a busy week in terms of evenings? Out?
Yes,
what are you up to?
Every night.
Sunday, he loves it. He does. I'm stealing that from
you.
you. Thank you, Steve. Right, follow me. He is funny. Right, okay. So there's a lot of machines that they've got on the stand. They're kind of back to back with one another. This man is so nervous about going on camera. Chaz, you can't be nervous. Are you nervous?
I'm a little bit nervous, yes.
Don't be nervous.
First time ever.
First time ever. They haven't seen this yet.
Haven't they?
No.
Right.
So,
can we edit it then?
No, okay. You can't edit it. I've been seeing this on social media, so I don't know if you have already. Let's do the grand reveal.
Yeah, well...
Chaz,
Star Falcon.
This is amazing. This is so cool. You should be really proud of this, you and your team.
I am proud. I am proud. Everyone's performed at the highest caliber to get this, part to fruition, really. Yeah.
Can you tell me about the journey? Actually, for starters, why? Why have you done this? Because I said at the beginning, you said we're engineers, we like to have fun.
Yeah, we like to be creative. We like to make parts, and you know, I've always done it all through my life. Whatever I put my head into, I'm going to make sure I see it through.
You're quite a character at Star. When I go out to your case studies, people always talk about you.
Yeah. It's been a long journey, 20 years now this year, coming on to 21st. But yeah, it's
still loving it.
I still love it. I get to play with the latest machinery. They give us free rein on how to, make parts and
push them
do
to
demos.
the limits.
Yeah, absolutely. Push everything to the limit. So, I mean, the design started,
that's what I
2 years ago. About
just lift the microphone up a little bit. We just want to hear you.
So the design started about 2 years ago, just after MACH 2022, and
so 2 years.
Yeah. It's been on and off though, not full time, but we've been designing it. Alec came up with the idea. I created the 3D model. We fettled with it, tweaked it here and there, and
I just told that.
and then eventually by Christmas this year, 23, we finally produced the final model, and then we allocated machines and engineers, and this is from my vision on the 3D model to what it looks like now. It's surpassed it.
Really?
Yeah, it's surpassed it. Because you couldn't get all the detail on the model.
Yeah.
But you could on the actual part now, you can see all the detail.
It's so good. Honestly, the finishes, the detailing. What we are going to do is we're going to take you on a tour with Rowan around the machines to see how it's been made and get a little bit more detailing on it. Does it push you? Because there's an event I do, right? I do this event and I do presenting, obviously, in different places, called Firework Champions. And basically, it's the best of the best, but they're kind of against one another. So It's like your brains are pushing people, but only through passion to do the best that they can.
This is my passion. I love making stuff. I love making stuff, and it takes you to a different level. It takes you to a different level.
I love that. It really is. It's that you must sleep and think about this.
I had a few sleepless nights, yeah. Especially the assembly and how am I going to pull it off, and with the help of all the engineers, and Alec, we were able to succeed.
Is it Stephen who sent a message in? Stephen Rowland on Instagram has just sent a message in and said, Chaz, you're legend.
Thank you very much. Thank you very much.
Yeah,
what
there you go.
Say?
And it's his first day. He was so nervous, and I said, Chaz, it'll be great. But I think, in all honesty, when you know your stuff, Chaz, you got nothing to worry about, because we're only going to ask you what you know, and it's passion.
Absolutely.
Passion shines through.
I can only tell you what I know.
Yeah. Oh, it's brilliant. Right,
Thank
okay,
you.
we are limited on time now, so I must say a huge congratulations to you on this. It's been a great success, and I've been going on social media, on my LinkedIn and everything, and I've seen these, and people are so proud. They're posting it in front of their companies. So actually, I'm going to encourage you to do that. If you do come to the show, if you do manage to get a hold of one, get pictures, get it out there, give them exposure in short supply. Well, exclusive.
Exclusive supply, yeah.
But get the pictures of it out there. Just get it out there, because this is, you should be proud of this. So this is pretty cool,
Thank
Chaz.
you. It has been good.
All right, I'm going to steal that from you. Thank you for going on camera.
Thank you.
Hopefully we'll see you more on camera. And we're going to go find Rowan, who is with Alec. Thank you, Chaz. Over here, just to kind of talk about the processes, because this is a huge part of what they're trying to showcase, at MACH. So Alec, this is for yourself.
Thank you.
And Rowan, this is for you. We praised Chaz, and he said he's had sleepless nights over this. So.
Sleepless nights over the past, how long has it taken?
About 2 years.
2 years! Oh, 2 years! It's finally done, the project is over, and it's a beautiful project, really. You've seen the component now, you've seen the assembly. We're going to dig into the actual components now, aren't we, Alec?
We are.
We're going to start with what?
This is the cockpit. So we're doing this on the R4. Obviously, split into two operations. So we've got the detail that we're generating on head one, which is this area here around the cockpit. We're using a 0.5 millimeter ball nose to get into those really tight corners.
Yeah, and there's some tiny, tiny features here. You look at the little tiny internal corners, which are really hard to achieve with a ball nose. There must be quite a long cycle time scanning that out.
There's a lot of scanning involved in this part. Most of it in fairness, is on the back end where we're trying to generate this 90-degree sort of elbow feature. So again, 1/2 mil ball nose, finishing that off, creating all that detail, taking away all the burrs, etc., etc.
Yeah, and if you notice, every single one of these components, if you can hold it there, every single one of these components has been deburred. There's no sharp edges,
That's the idea,
no
yeah.
burrs to cut the I guess the lovely customers you're handing these out to. And what's interesting as well is this 90-degree bend. If the 90-degree wasn't on it, you could turn that easily.
Easily, but there's a lot of 3D scanning, XYZ scanning involved in generating all those curves, making all those nice blends.
Yeah, before
on
we
the
move
back
on to
end.
the next component, what I find fascinating is, I mean, do you think that components are getting more and more complicated as technology improves, the manufacturing capability improves, but also designers and product designers can change what they want to make?
I think so. I think there's been a general trend over the last 10, 12 years where more and more companies are using 3D data. And obviously you can generate a lot more complicated parts with 3D solid model. So
Yeah.
definitely, there's a definite trend of getting more and more complicated parts.
Absolutely. And let's move on. We've got loads of components to show you exactly how they've been made. So that was on the R4, the SR20 R4. And we're moving on to another one of the Star machines.
This is the SD.
So the SD, slightly different machine, but equally as complicated a feature. There's what I think you'll find in a lot of these components, there's a lot more milling than you'd expect from a sliding head lathe here. So, sorry guys, hello. How you doing? So the SD, obviously a bigger machine with much more tools associated with it. What component have you made on this?
So we did two. We did what we call the thruster. We did that pre-show.
Yeah, so the thruster's kind of the back of the Falcon
It's
here.
the back of the
That's
Falcon,
the
yeah.
engine, right? That's
Yeah.
driving
So
it forwards.
That one was pre-show.
And this is, I mean, you look at this originally, you might think you want to do this on a milling machine, wouldn't you? You look at this, well, I'm going to mill the outside of it, drill a few holes in it. But
to be
it's
fair,
all
majority of the parts are all prismatic parts, so
Absolutely.
there's not a lot of turning.
Yeah,
at
absolutely.
all. And then this is the hull. So again, there's about 20 or so tools involved in creating that. Most of it, to be fair, on head one, because we've got more tools on head one on this particular machine, but there's a lot of detail on that. Superb surface finishes. We then pick it up in a square profile collet and just finish the detail on the back end to finish it off.
So if you look at the component as well, what's fascinating is if you put this on a milling machine, imagine trying to put it in different setups, set it up in the vise.
Yeah, you need a fourth axis.
You need a fourth or even a fifth axis, really, wouldn't you? And
so
even if you
pretty
do that, though,
complicated.
it's quite complicated to automate a 5-axis machine.
It is.
So instead of you
good.
put this on a sliding head lathe, you kind of get automation for
One hit
free.
machinery, it's coming off in one.
Yeah, amazing. So all those components, no matter how complicated they are nowadays, you can automate them, and you get sliding head companies generally they'll be making kind of sometimes in the hundreds of thousands of
Absolutely.
volume.
So it's all we do part volumes from 50, even less than 50, up to millions. So it all works on the sliding head machines.
Yeah, absolutely. And we've looked at the machine inside on the SD here, and the complexity of the machines it kind of amazed me every single year. Complexity, but they're not that hard to start to run once you get used to a sliding head machine.
Yeah, obviously the coordinate system is inverted
Compared to a fixed head,
Compared to
yeah.
a fixed head. So once you've got over that, as I said before, it's like 10% Star command system, sort of 90% FANUC command system. So if you're generally used to FANUC controls, it's not a difficult machine tool to get used to.
Absolutely. And with the two driven heads, you have two separate areas where you can do the machining simultaneously as well.
Yeah, you've got head one, lots of tools on head one, and then we've got 10 tools on the back working station, 8 of which have got driven tool capability.
Yeah.
So the idea is, for the best sort of cycle time, is to overlap as many of the operations you can onto the back spindle. That reduces the cycle time and gives you the best efficiency.
Absolutely. So with components like this, where you've got real complexity and probably quite a high cycle time because there's lots of scanning.
There's an awful lot of work on this part, so the cycle time is significant. I think we're up to about 10 minutes or so with all the milling involved, etc., etc.
Yeah, which is quite high for a sliding head machine.
Yeah.
But you can minimize that by doing everything as simultaneously as possible.
Absolutely.
Yeah. Okay. So let's move on to the next component. What are we going to be looking at, Alec?
We're going to look at the SX. At the show, we've done two parts. We've done the bow and the stern. So
Yep.
the SX is around the corner.
Okay, we'll go around the corner and you can see how many machine tools there are on site here, showing the sheer range of the Star set of Star machinery, which fits a huge different range of applications. Let's have a look at this.
So This is the bow. So on this machine, there's about 25 tools involved in creating that component.
Wow, and it's for such small components.
Most of the detail is done on head 1, awful lot of scanning involved on head 2 as well. We're picking up with a profile collet on this oval part of the component there. So that's the bow, and the back end of the Falcon is the stern. Again, similar, we're picking up with the same collet on the back, but again, lots of tool paths involved in generating that part.
Almost dropped it.
With a little bit of engraving in the middle, and obviously a nice tool path to generate that sort of feature on the back.
Yeah, it's brilliant. So some really good use of CAD CAM here as well to offset the profile outwards to get a nice tool path. What I find fascinating though is the profile collet. And when people start to make more prismatic components on a star sliding head, rather than holding up on a standard diameter accurately, you then have to start holding on this odd profile. Now, how do you produce one of these collets? And are these
basically we just mill that profile into the collet on the subspindle. So it's not overcomplicated, to be fair.
Can we have a quick look at it now? I see the door open light is on, so I can open the door here. And then you mill into this side here is where you can hold on to that component. And are these kinds of collets being used more in industry?
Well, we call that an emergency collet.
Okay, the emergency collet, brilliant.
So it's soft, so it can be machined. It's got a 10mm extension on it, but it's very easy then to generate the profile in the face once you've got the toolpath set up.
Brilliant. So if you're really in a bind and you need to hold something awkward, you can just mill that out and then clamp on it properly.
Emergency collets, they're off the shelf.
Off the shelf, fantastic. Okay, so check out your emergency collets from Star. Is that the code number?
Yeah, F48
in the stock system. Collet. Yeah, fantastic. Okay, and we've also got a few smaller components to show. We have some components that have not been engraved, they've been embossed, and you made sure to mention these to me because the embossing required. Oh, here we go. The embossing required. Yeah, here we go. This tiny component here.
So this is the turret. This is done on the SR20J2 Type B. So there's two types of this part being used on the assembly, but the embossing there includes a 0.3 diameter end mill.
Yeah, and we're getting almost into micro machining territory. I asked you a little bit. Is this micro machining? It's not quite, but it's getting very close.
It's very close, but yeah, it's about cycle time of about 5 minutes on that to generate all that embossing and create that feature.
Absolutely. Look at the really sharp internal corners here. I mean, it's just the Star logo, but embossing that rather than engraving it is a lot harder. One is a lot harder than the other.
It is, and it takes a long time to generate that because of the amount of toolpath that's involved. So yeah, it was definitely a challenge, but again, they've done a fantastic job.
Yeah, absolutely. So the whole assembly coming together as well. It's a really nice fit, and it's fastened together. Let's see the finished component. And when you see it completely put together, you're like, well, that looks like a finished product. Absolutely gorgeous.
There's a definite wow factor to it, and that was what we were trying to generate for the show.
Yeah, definitely. And how do you see Star moving forwards in terms of showing off more technology? I mean, there is almost zero turning on this.
The process starts again. As soon as this show is finished, it will start, and we'll start thinking about what we can do in MACH 2026.
And how do you show even more milling on a Star sliding head lathe?
Well, we might flip. We might go the other way and just make some more round parts instead of prismatic parts. I don't know yet, but yeah, the process will certainly start soon.
Yeah, absolutely. We love round components as well. I'm sure a lot of your customers still make components, connectors and fasteners and loads of different kinds of round components.
Yeah, but this detail shows off what the machines are capable of, and that's what we were trying to get across with the show.
Absolutely, and the really beautiful 3D scanned surfaces you get on here as well are a real testament to how the milling technology has come forward in Star Machinery.
Well, all our machines are mill turn centres, to be fair. Obviously, some have got more functions and features than others, but I think, the complexity of that assembly does showcase what the machines can do and how well they can do it.
Yeah, absolutely. And what's been the reception of customers looking at a component like this?
It's gone down a storm, to be fair, so we couldn't have hoped for a better outcome. Yeah, almost everybody that's visited the booth has
asked for one.
Been asking for one.
Yeah,
so
of course they have. That's always a good sign.
It's really gone down well, so we're happy with that.
Yeah, fantastic. Okay, so if you want to see some more from the Star Falcon, you're going to have to come down to the booth soon. Yeah, next 2 days. We've only got Thursday and Friday left here at MACH 2024 on the Star stand. If people want to come down, what can they see on the stand?
We've got all 8 machines running. We're not just making Falcon components. We've got another couple of components on the machines that are interesting and show some of the functions that we've got available. So there's a lot to see. So we welcome anybody.
Yeah, absolutely. So, well, you're welcome down to the Star stand to see the Falcon for the next 2 days. I think we have a question as well coming in. Yeah, come on, Lindsay.
I'll jump in between you. Right, okay. Nice greetings from Mexico.
Oh, God, yeah.
Yeah, they're global.
Fantastic.
We're going across the globe. But also, these are incredible demo parts, but what are the real world applications? Because of course you're showcasing this for here.
Yes.
But I mean, it's pretty endless, isn't it?
It is, but it does showcase the prismatic machining capability of our products. Like I say, there's some turning on these parts, minimal turning, but most of it is prismatic machining, and that was kind of like the emphasis that we wanted to put on for the show, to showcase the milling capability of all the Star machines, and I think that does it perfectly.
I agree. Alec, industry-wise then, I don't know if you've covered it, what industries are people in that go, I need to start considering Star? I know that's a big question.
It's basically, if you're making small prismatic parts and you want to make them more efficient, our machines are all about being efficient, building that automation into those components. So I think that, that shows it very well indeed, in that we're making really efficient parts because we're making them out of bar stock. There's no multiple setups. It's one setup, one hit machining. So it's productive, it's efficient.
Right, brilliant. Alec, thank you.
You're always welcome.
And also, you too are welcome to come onto the Star stand. They've got hot dogs as well, don't you?
We do.
I've got Jake, our camera. Oh, sorry, I forgot that. I forgot to do my job there. Jake is there going the hot dogs. He's very, very excited. He's rubbing his belly at the moment. So, yeah. You've been enjoying them?
I haven't had one, to be honest. I'm so sorry.
Not yet. I've not had one either yet.
Oh, okay.
But Jake did say, actually, I asked him what happens when you have a hot dog. He said you smile, and I can't wait to smile.
You smile.
So
there
I'm
we
gonna have a
go.
hot
So if
dog.
you want to smile, come over to the Star stand during MACH. There's loads to see here. They've got machines that are backing up next to one another. Let's just finish off here. Alec, you can come over in the close as well. Do you like the shows, Alec?
I do. It's a lot of sort of stress building up to this show, but I really, there's a fantastic buzz, fantastic vibe at this show, and especially when we're doing stuff like this, it's a really good week.
You get to show off your work.
We do.
You do. Okay, well, thank you for watching. Stay tuned because we are going live throughout the day. And of course, we've got the podcast happening at 4 o'clock this afternoon. Have you enjoyed your walk around? Have you been educated?
Absolutely fascinating. We've seen some of the components that Star produced before, and they were brilliant, but this is, it's up there. It's probably one of the best, maybe even the best. And it's a testament to the 2 years of effort that Chaz and Alec has put into it. So
yeah, I said you've got 15 minutes, Ronnie went, that's not enough. I think that's not enough time.
No way. We didn't even cover half the components in this thing, so we're going to come back.
Right, stay tuned. 4 o'clock podcast.